So girls, last lesson you just found the volume of a cylinder, and you know that the formula is area of the uniform cross-section for a cylinder times the height. And in this case, it was volume, area of the uniform cross-section is pi r squared times height. That is the volume of a cylinder formula. Look, you can do these questions two different ways. You can just find the area of the cross-section first there, which is a semicircle, and times it by the height. Or you can say, I know what the volume of a full cylinder is. It's pi r squared h, and then halve that. So it's up to you which way you want to do it. There are two ways to do this. The first way is the area of the semicircle, which is the uniform cross-section, which is what? A half of pi r squared. This is the first way to do it. Look at what the uniform cross-section is, work out its area, and then times it by the height. So area of that semicircular uniform cross-section is what? This is one way to do it. A half times pi times, what's the radius?
3.
Diameter is 6, radius is 3, height is 12. Times 3 squared, which is what? 9 pi on 2. And so the volume is area of the uniform cross-section times the height, which is 9 pi on 2 times 12. This is one way of doing it. That's 9 sixes. 54 pi kilometers squared. I know you know how to work that out if you had to. Or you can just do it all in one step. That's doing the cross-section separately and then the volume. Or you just say, I've got half a cylinder. You okay with that? The other way is to say, I've got half a cylinder. That's the good thing. This is actually a good way because with volume, it's different to surface area. It's much easier. You can just say, I've got half a cylinder. The formula for volume of a cylinder is pi r squared h. This is the other quick way. A half times pi times 3 squared times 12, which is 54 pi kilometers squared. So girls, with volume, kilometers cubed, thank you. Kilometers cubed, that area was kilometers squared. So girls, with the second one, there are two methods. You can do the area of the annulus ring cross-section and just times it by how far back it goes. Or you can do the big cylinder and you're drilling out or cutting out the small cylinder. So there are two ways to do it. So I can say volume is, if I want, big cylinder, cut out small cylinder. Does that make sense? That's one way. I want to show you both ways. So the big cylinder is going to be pi r squared h. Notice I'm doing capital R. And the small cylinder, I'll go pi r squared h. Are we okay with that? What is, for the big cylinder, what's the radius? What's the radius? Well, it's half of 9. 4.5. And the small cylinder, what's its radius? So I've got diameter of the big one's 9. Diameter of the little one is 3. So it's 1.5. So girls, you can do big cylinder minus small cylinder. Do the big shape and cut the small one out. So that's pi times 4.5 squared times. Do they both have the same height? Yeah. Good. Brackets minus pi times 1.5 squared times 8. Now, you can work out each one separately if you want. I probably would. What's 4.5 squared times 8? And you don't need to stick the pi in. 2.25. Is that one 20? No, it's not. Volume of big cylinder minus volume of small cylinder, one shape, and I'm solid and I'm cutting out the other solid from it. Then that's how you would do it. Method 2 is to do the area of the uniform cross-section, which is the annulus. How do you find the area of that? Isn't it big circle minus little circle, which is pi times 4.5 squared minus pi times 1.5 squared, which is, anyone? Which is? Is do uniform cross section first, so the area of the cross section first, you do that, big circle minus small one, and therefore the volume, this will be meters squared, the volume is 18 pi times how far back that shape goes, which is 8, and it's millimeters, by the way, millimeters squared, and then you'll get the same answer, 144 pi millimeters cubed. It's up to you, whatever you like. You can do either method. They're both equally fine. Okay, we're finding the volume of this solid. We need to work out how this shape is formed. Now, to me, what do you think? Do you think you had a square and then what got cut out of it? Then the quadrant got cut out of it. That's how you get that shape. You start off with a square and then you cut that out. Do you see? You cut that out. Can you see it now? All right, so what's the area of your square? So the area of this is 4 times 4 minus, how do I do the area of a quadrant? So this is just a quarter of a circle. A quarter of pi r squared. Isn't it a quarter of a circle? So I've got my square minus a quarter times pi times what? 4 squared? What's a quarter of 16? 4? That's your area. And now, volume. I know you know how to work that out on your calculator. I want to keep it in exact units so that we can practice. Can you see it, girls? So I think sometimes for difficult shapes, I would definitely be doing the area of the uniform cross section. Okay? Now, volume is that area times height. So can I put the height first? Because it's 6 times all of that. Do you see what I've done with the brackets? You okay with that? That's the height. That's the area. How am I going to expand it? Girls, I want an exact answer, please. What do I do? 6 times 16 is 96 minus 24 pi centimeters cubed. That was centimeters squared. So I put the height times the area, so I knew I was going to have brackets to multiply by. You could then work it out if you wanted. Or you could have worked this out on your calculator and then just times by 6. But, you know, we want to get used to using exact units. And what we would do in this case, if we were to multiply that by 6, it's 6 times all of it. How that shape would get formed, you would have the rectangle and cut out half the circle to get the cross section at the front.
So you do 10 times 20 times 20, and then you cut out the
Of these, question 13, I would do the area of the front face, the uniform cross section in this one, which is just the rectangle, cut out the semicircle. So just do the area that I'm pointing to now, and when you've got the area of the front face, times it by 20 once. See, with these, I wouldn't be doing solid minus solid. I think that's too hard. Do the area of the front face. What about this one? You would do the rectangle area and the sector. Let's just do that one now. Girls, I would be doing the front face, uniform cross section, definitely. What are the dimensions? 8 times what? Yeah, just be careful. Notice I went like that with my pen to make sure I'm getting the correct dimension. 4 is 32. Plus, we've got that fraction of a circle, which is 30 over 360 times pi times 8 squared. Girls, I think you'll remember for this section, just do that. Don't add the 32 on. Otherwise, it'll give you with the decimal. Do you know what I mean? So if you do this on its own, I think that's 1/12 times 64. 5 1/3. 5 1/3. Is it 16 over 3? Someone, yep. Yes, yes, yes. So that's the area. And so the volume, if you were to do an exact answer, I'm not saying you have to, but we're just practicing exact. You could actually have just worked that out on your calculator. All right. If I was to do exact, what do I now multiply this area by? So volume is that area times the height, which is 7. So I'd go 7 bracket if it was to be an exact answer. Girls, you're not going to be asked every question as an exact answer. I'm just practicing it for you. I know you can just put that whole thing into your calculator, but I thought this is really good practice doing exact. So we would multiply if we had to. So what's 7 times 32? It's 224 plus 7 times 16, 112, pi over 3. That is an exact answer, but girls, of course, you know you could just get that answer on your calculator and times it by 7. All right? Units, meters cubed.